This video will help you with the homework questions on number 14. Number 1, create a scatterplot and labels for the given data and draw a line of best fit. So this scatterplot talks about time spent practicing, that's our independent variable, and our points scored, that's our dependent variable. So let's start with those labels there. The x-axis will be time, and the y-axis will be points. And if my handwriting was neater, I would write the whole word out. Time spent practicing and points scored. The next thing we need to do is choose a scale for our number line here. So my data starts at 0. So my time spent starts at 0 hours and it goes up to 33 hours. So what I need to do is choose a scale that will span the range of 0 to 33. So I'm not going to go by ones because there's only 12 marks. And if I go by twos, so 2 by 12 would only get me up to 24. So I'm going to go by threes. So that makes my first one 3, this one is 6 and 9. And you don't have to label every line, like you could skip every other line if you wanted to here. 15, 18, 21, 24, 27, 30, 33, 36, etc. Now let's take a look at our y-axis, which are our points scored. And I need to go from 6 to 38. Well, this one went up to 36, and I need to go a little higher than that. I need to get up to 38. So I think I'll go by fours, right? So 4, 8, 12, 16, 20, 22, 24, 26. Oh wait, I started counting wrong. 4, 8, 12, 16, 20, 24. I started counting by twos all of a sudden. 24, 28, 28, 32, 36, 40, 44, 48. All right, let's start getting some data on here. So the first point is 0, 6. So 0, 6 is going to be halfway up between 4 and 8. 3 and 14, well 3 has its own marker here, and 14 is halfway between 12 and 16. And 7, well that's going to be a little bit after 6. 7 and 16 is right on the line. And 12, is this one here, is also at 16, right on that line. And 16 with 28, that's here. And then 25, it's right past 24, 25 goes with 36 right here. And then 33 with 38. It's going to be right past 36, halfway up. All right, so our data has been plotted, our scale has been determined, our labels have been made, and now I'm going to connect, well, not all these dots, right? So we're making a scatter plot, and when we draw a line of best fit, we don't connect the dots, right? That is not a line at all. So a line of best fit is merely a straight line that goes through the middle of the data, right? So I'm going to put an arrow here at the end. Now I'm not going to put an arrow down here at this end because having negative time wouldn't make sense, right? So having negative time wouldn't make sense here. But I can certainly have more time spent studying. So as you can see, as my time value increases, right, as I move from left to right, my time is increasing. And when I look at the data, the points tend to be increasing. So if you need to identify the type of associations shown in the data you graphed, I would say that this line of best fit has a positive slope. So therefore our data has a positive correlation. In the second box here, we have to find the solution to a system of equations graphically. So we're looking for an ordered pair, right? That's an x and y value, and that needs to satisfy. So it satisfies both lines, right? So you are a point on both of those lines. So that would be this intersection point here. -1, -1. And a point that is on both lines or satisfies both lines here would be the ordered pair 1, -2. And you'll see in question number 4 that these lines don't share any points in common. So there is actually no solution because there is no point that satisfies both lines. All right, let's turn the paper over and solve some equations. We're going to distribute, right? -8 times 1 is -8, and -8 times 7n is -56n. Don't forget, when two variables are on the same side, you combine like terms. You do not use an opposite operation. So this would give me -61n. The -8 comes down, the equal sign comes down, and the -8 answer comes down. And now I'm going to use an opposite operation here, right? This is an additive inverse, right? And I'm going to write it on both sides, so that's the addition property of equality. And it looks like I get a cancellation on both sides, right? Additive inverses are two values that sum is 0. Now on this side, I'm not going to write the 0 because adding 0 to something doesn't do anything. But on the other side of the equation, I do need to write the 0. I do need to show that that side of the equation is now empty. So when I finish this problem by dividing by -61, I get 0 as my final answer. All right, question number 6. Multiply by distributing this -6. So +42 and -6 times -x is +6x. And the rest of this over here, this will stay the same, but you see this minus sign outside the parentheses? That needs to be distributed. You can think of it as distributing a -1. So -1 times 1 and -1 times 7x. This side has two constants, so I'm going to combine these two items here. I'm going to leave everybody alone on this side. 36 minus 1 is 35. And now I'm going to, let's see, I'm going to add 7x to both sides, and I'm going to line it up with its like term. And that gives me 13x. And now I'm going to subtract 42 from both sides. And let's see here, I think I'm going to get 7. Divide by 13. And that's a pretty nasty decimal, so I'm going to leave it in fraction form. Okay, last question. Alright, let's move along here. The next box for Thursday says a cook uses 2½ cups of flour for each ounce of butter. So 2½ cups of flour for 1 ounce of butter. Now none of my scales go by 1 here, right? None of them have a value of 1. So I'm going to try renaming this so that the butter amount is 2 ounces. So in order to get from 1 to 2, I need to multiply by 2. What you do to the denominator, you have to do to the numerator. That's going to give me 5. So I'm looking for a graph that has a value of 5 cups of flour, 5 cups of flour for 2 ounces of butter. Nope, not this one. 5 cups of flour for 2 ounces of butter, not this one either. So this one has 5 cups of flour for 2 ounces, and this one also has 5 cups of flour for 2 ounces. So the only other thing I need to check is this value, the 0. So if 2½ cups is 1 ounce, how many cups is 0 ounces? Well, the multiplying factor here would be 0. So this is the final answer. I'm done.